Okay guys, so haven't really done a video in a while, just been pretty busy with all sorts of things really, so thought I'd just do a quick update as of at the moment, what I'm up to, what I'm doing, things going on, like the bits and pieces in the garage and whatnot. Got Variax to do over there. I've got just about to do another video on phasing, which should be pretty cool. I'll do after this, and just generally all sorts of bits and pieces really, so yeah. Couple more photos on the wall, so as you can see, lots of pictures. Dad's been busy putting those up recently, which is pretty cool. Yeah, and some rendering on the outside of the garage. So the outside is pretty rough at the moment really. It's still the old door's just been bricked up on the other side of the GEC plate there where the old door used to be. So that's bricked up on the other side there, and of course the new door. This is where the new door is now. Well, I call it new, it's been here for about nearly a year now, so the old door's just been bricked up on the outside. It was boarded over when we first did the ply. But yeah, anyway guys, so just got a message. So yeah, I'll just show you what I've been up to really. This is I've got a few of these probes, as you can see. I've bought a few over the last couple of months really, and before that I think I've had that one for quite a while now, and that one there also. But I got one sent to me with like a bent, it's like obviously got warm, you can see, and the actual plastic's distorted on that one there, so that's not ideal really. So I bought another one. It is actually in fact the other end of these internal parts here, just for the red part there, straight from China. The guy couldn't tell me what the condition of it was for whatever reason. I just thought I'd take the risk with it really. It wasn't too bad. It's a little bit more scuffed up than this one, and it's got a few little blemishes in there, but nothing that the a buffing wheel couldn't take out, So yeah, I swapped that round. So that one's fully working now. I've just swapped over the red part really. There's the old red part with the bubbles in it. That's the new red part, all fully fitted on there, and that is the remainders of the old probe that came in the post. And he said the cable had been cut off, and that's all he could really tell me about it. And he lost the nib of it. Managed to lose that, but I wasn't really after the nib anyway. Hence why this has actually worked out quite nicely. So yeah, that's a 999 meg resistor, or close enough to a gig ohm really, nearly 1,000 freaking meg ohms. So that's quite a bit. And then there's a little what is that? I think that's an 11 meg ohm. No, 1.111 meg ohm resistor there. So it's just a voltage divider really. It's designed for up to 40 kV DC, and it'll just change that for a ratio of 1 to 1,000. So per, say 1,000 volts on there, you get 1 volt between this resistor here and ground here. So that's how they work really, just a voltage divider, or an attenuator if you want to call it that as well, I guess. But yeah, that's how they work. And you just hook it up to your multimeter. I've got another one hooked up to the multimeter there. Very important to have a really good earth connection on these guys. Make sure that is definitely earthed, because otherwise you're the flow, the return path for your ground reference for the voltage divider means that without an earth reference on there, your multimeter also is wherever the voltage you are measuring on that. It just doesn't really function properly without a ground reference. The multimeter would be the same voltage, which is not ideal. And it's not going to give you a decent reading at all. It's more likely just to give you a belt or a shock or something. You're not really wanting to get the kind of shock off the end of that on your multimeter. I usually always just keep them on the bench anyway when I'm measuring, keep it earthed up. So yeah, that's how they do, that's how they work, and how to use them safely. So I will be doing a video after this one showing phasing of these low bit transformers, using the oscilloscope over there with a couple of these probes. Now these ones I actually got off eBay. They were going pretty cheap on there. They're on there at the moment. They come in cases, they're ex-MOD, but these are old style ones, as you can see. They've got the old style Fluke logo on there, upside down. But they are absolutely immaculate. I have to admit, that is as if it's probably ever been used once, if not ever. That's like brand spanking new, but old. So new old stock is the best stuff. So yeah, ex-MOD, those are on eBay at the moment, so highly recommended. If if you guys want to pick up a couple, you know, for a decent price, they're on there. Just search Fluke AK40s, and there you go. You got yourself a score. So yeah, go for those. So yeah, I'll be showing you how these interact with these transformers and the oscilloscope in a bit. So yeah, that's that project. And I have no idea what that's all about. That's what Dad's up to. I'll leave that to him. But yeah, I'll show you the Variacs at the moment. So I've got a Variac project going on at the moment. So I'm restoring this one here. As you can see, it's taken all apart. I've lacquered the top. This is the Berko Rotary Regavolt Type 74A 15 amp Variac. That's the project box for it. I've taken it all apart. So it's all together in there, apart. So yeah, so I've re-varnished the top, or re-lacquered the top there with some nice high voltage rated lacquer. I think it's polyurethane type stuff. And I've also, as an experiment on this one, I've actually lacquered over the top of the commutator after I polished it. So I polished it. It was originally black. It was black as the Ace of Spades. You know, it was like very similar to this one down here. You know, pretty, maybe even blacker than that. So yeah, I've got it to a nice shine now, as you can see. I've started cutting a bit of the original lacquer off, but I plan, this is an experiment really, to sand that smooth. And what's going to happen is that I'm going to have sanded down to the commutator, and then the remainder of the insulation will sit in between the windings here. So you'll actually, hopefully, not get a build-up of carbon in between the windings, because you can get gaps in the windings. It's not quite fully gone down in there. It actually shrinks. The stuff shrinks after it starts drying, which is a bit of a pain really, as I wanted it to be exactly 100% smooth like that area is there. But the outside it's shrunk a bit, so it's not really a perfect experiment, but at least it will help a bit anyway, so I thought it was worth doing just an experiment, see what happens on this one. It needed it anyway, because it's got some scorch marks, some hot spots it had originally on it, so from where someone's tried to overload it, probably, you know, putting a nail in the old fuse trick and whatnot. You know, you think 15 amp Variac with a 13 amp plug, it's not likely to do that, but they've been doing something with it. They managed to do it. I'll show you the other side of it. It's not too bad. You can see the couple of burns there really, but nothing too bad. Nothing that the polyurethane could sort out really. Still works fine. It just doesn't look very pretty to the eye, but that will be on the inside anyway afterwards. It's all functional. But yeah, it's also got a cracked terminal plate there. See, they tried repairing it with they did actually repair it, not bad, with some Perspex, just a plate over the top, drilled the holes in the right places for everything, just mounted it on, and that seems to fix it. And that's probably from, I can imagine this thing probably being plugged in and then for some reason like dropped on the floor or something, you know, and it's just the Variacs kept going and the plugs like pulled the whole terminal plate off the side of the Variac. You can imagine, yeah, this is loose at the moment, the whole thing wants just to pull out away from the Variac, because these things are heavy, you know. These are like, that's a 13 kg, that is altogether. No, that one is, sorry. That's 13 kgs altogether, that one. This isn't far off because it's the same amp rating. But yeah, so it's just got a lot to say about it, really, a lot of stories, you know, for its age. It's pretty sure that's its date code there, 1974, so it's over 40 years old, you know, it's like proper vintage stuff. As you can tell, Berko was bought out in 1973 by Claude & Lion, so anything before 1973 will be Berko. So you can tell basically how old it is based on the fact it's a Berko, you know. So this one's fairly old, that one's a bit newer. Not sure what the date code is on that one. Was he 80 something? 84, yeah. About December 84, 50th week. So yeah, this one's fairly much older than that one basically. But yeah, I was actually going to start on this Regulac to begin with, but I decided to do the Berko Regavolt instead, because of the fact that inside the Regulac is not a Regavac, a Regavolt, which is fairly unusual. And also, that is a Regulac dial and a Regavolt knob, because a Regulac knob looks like that. That's a proper Regulac knob with the top part with that little groove in there. Looks just like that. Now this one is a Regavolt knob because it has the dome on the top. So I'm calling this a Frankenstein repair. By the look of it, it's been made out of 2 Variacs to make this, and for whatever reason, it's just ended up like this. But it's pretty tidy, really. I just, it's all loose. I've taken it apart already. Show the inside. Straight off. Right, so yeah, it's pretty tidy now. There's screws, left the screws inside. But particularly like 715s because they have a golden commutator. I'm not sure if you can see it just inside there. There's actually, the commutator is gold plated. Might be able to see it just shining there. So not only is it nice copper underneath it, like this one, but also this is gold plated on top, which makes for an excellent commutator contact for the brush, which is perfect. It's very nice. Very nice. This one, as you can see, no burns, nothing whatsoever, except for, not sure if you can see it on the edge here, there's a little hot spot which has probably come from not actually overloading, because you'd expect the whole thing to warm up, but there's a little blemish just there, and there's another one around the other side about the same size, and that's probably just from where the brush hasn't quite contacted quite well enough in that position, or something along those lines, maybe an inrush, something like that. But otherwise it's a perfect condition, really. It's another nice Variac, but I don't really want to put it back inside the Regulac box because it's a Regavolt and it's just too nice to want to hide it away inside there, you know. So I'd rather probably keep this Regulac casing for another transformer, and I would like to stick that one in it there, but that's not 15 amps, that's 13.5, so I don't really want to do that. So I'm actually on the lookout for another 15 amp to stick inside that casing at the moment. That's the decision I've made so far, but I'll come to that project when I come to it, really, so I'm going to leave that for now. It's far too nice just to fit inside a box like that. No, that's just blasphemy, you know, that's not cool. Can't be dealing with that. So I'm going to leave that project for now and continue on with this one, which is going to be much better, much cooler. So also another update is specifically went out and bought a installation tester. Something I've been wanting to buy for ages and ages and ages. This one's a Fluke 1507, and specifically interested in this one because it goes not only just the usual divisions like 250, 500, 1000. It's also got the low voltage ones for doing like the IS type stuff, you know, where they're a bit more sensitive, or electronics where it's a bit more sensitive to the voltages. So this one actually starts at 50 volts, goes to 100, 250, 500, 1000. So yeah, that's pretty cool, and I bought this from a guy on eBay, and he's done a superb job of actually packing it here, as you can see. He has double boxed it because it was inside this box and inside this box, and also it's completely wrapped in really good bubble wrap. Proper job, you know. So it's actually, there's no space in there for it to roll around or anything like that. So that's fairly good packing. So quite impressed with that. That's the proper way to do it, guys. You know, double box and make sure it's not any space for it to roll around or anything like that. So yeah, done a good job there. And more interestingly is yeah, as you can see, the meter is actually in a custom case, which is awesome because I've looked at this case on eBay and I thought, oh, I've never seen one of these before, and looked on the Fluke website and couldn't find anything like it. Sent a couple of messages back and forth with the guy, and he actually said his neighbour actually made this for him. You know, he gave him the meter, his second-hand meter, as I said. He gave this meter to his neighbour who makes these cases or these kind of materials. He's just worked with them. He's actually managed to fit a case specifically for the meter, and it's a really nice case, I have to admit. Proper attention to detail, you know, like Velcro on the back there. It's all nicely kneaded, nicely all sewn together really neatly. He's done all the edging, everything. That he's even melted the little frays and everything in the plastics just to stop it from fraying out or anything. He's even put little loops, 4 little loops on the front. I guess that's to put onto like a neck holder or something along those lines, so to secure it somewhere. And also he's made a clear plastic front on it, so it actually protects the screen and everything. And he's left a hole there for the knob to turn that around, and also the holes for the the probes are going to, which is really cool. I really like that. I don't actually have all of my meters in these kind of cases, but being a custom, it's a one-off really. So this meter's going to have it, but I'd love my other ones to, but I don't think it's going to happen. But that is a really nice case, I have to admit. It's even better than I thought it looked on eBay. You know, I thought it might not be so nice, but it's a bonus having it. But no, this is really nice. That is super duper handy. So yeah, we'll give it a go anyway. So I'll show you it working. A couple of leads on the floor. Drop down. Excuse me a second, guys. Just going to rumble around a second as I get these in. Alright, one. And this little bugger's gone back down on the floor, so just put it back in there. Yeah, okay. Right, so this is a Variac which is good for 0 to 275 volts, as you can see there underneath the tape. So we'll test it up to, can't go to 250, 0 to 275, and then plus the RMS, you know, like peak to peak, it's going to be more. So 500 makes sense for an actual test on this Variac. So we'll connect the little crocodile clip there to the earth, and then we'll use the probe, just made its way down to the floor again, and measure. This probe actually is pretty cool because it comes with a press button on it, which is pretty difficult to do otherwise, because you've got to try and hold two probes on. Say that was just another probe. Without the crocodile clip, it would be it's like a freehand job really. So this little button makes it really handy. But I've got a crocodile anyway, but it just makes it even easier to use. And you just put it on and press. You know, it's real easy. But there's also a test button on the meter. But yeah, cool probe. I like that. You see the little contact on the for the switch there, both sides. So yeah, pretty cool. So we'll try them out. So we got the earth one connected on. So we're going to measure the line voltage, which would usually go. Let's say one usually goes on neutral. So we'll try. Obviously, these are going to be all about the same, plus or minus whatever ohms the actual coil is. But for insulation resistance, you don't really need to go on to 1 really. So we'll just try out that one. Just press the. Let's get on a bit of contact there. Okay, press the button. Pretty slippy, man. Very shiny, that's the thing, is all these. Alright, try that. So 550 megohms, you know, or more than 550 megohms, so that's pretty cool, you know, that's a pretty good reading. So we can tell that there's no shortage to earth on the core anywhere, so you can tell that these burn marks aren't actually detrimental to the operation of the, it's not actually going to cause any problems like shorts halfway along, which is going to cause it to smoke and whatnot, actually be faulty. So it's worth repairing, you know. So yeah, that's what I've got this meter for anyway, because you only go so far with a normal multimeter on ohms, you know, can't really measure up to these kind of voltages. So if you wanted to be really sure about it, we could go up to 1000 volts. So yeah, it's going to get fun now. We're going into high voltage realms even, these kind of ranges. So try one again, and there we go, stabilizing about 840, 850 megohms. So yeah, that's still really high reading. So that's pretty cool. Now, just out of curiosity, this polyurethane, I've got a test little plate here which I'm using as a hardness tester. I can just scratch that with a knife first just to see how hard it is as it dries, rather than scratching around on this to see how dry it is. I'd rather just have a little test plate to do it on. I put a big blob of it on there as well, which is actually the skin on top of the original jar, because I'd left it with the lid slightly off and it actually got a bit of a skin on top. So just plonk that on there, and at that set, as you can see, it's a bit squishy still. Yeah, so just out of curiosity now, if we take this one and stick it on 1, and that is now connected to this side of the winding all the way around, and it'll still be a megohm reading to this point here. So you can actually take the probe now, stick it on the polyurethane insulation, and just test how good a dielectric that is at 1000 volts. If I press the button now, go over there. So if you look at that, that's more than 11 gigohms. See that? G ohms. So that's 11,000 megohms. You know, that's a serious amount of resistance there. So this stuff is seriously good as an insulator. I can even put this on, excuse me a second guys, on the aluminium plate. Okay, okay, and measure the thinnest part, not the thickest part, the thinnest part of this insulation, which is probably just there. So get on there. Look at that, guys. 11 gig ohms. Let's try squeezing down into it to actually pierce the insulation a bit with the probe, and you should see it deteriorate. There you go, down to 0. So it is eventually pierced. You can see the pierce mark just there, that tiny little mark. But yeah, it's a really good insulator, as you can see. There's actually a bubble into there. Look at that guy. So yeah, seriously good as a insulator and that stuff. So pretty happy with that. I'll be sanding the rest of it off the top of the commutator sometime later this week, and also the paint will be arriving, the Hammerite paint, to paint the outer casing. So yeah, before I get too long in this video, because I've only got so much memory left, I'll leave you guys to it, and yeah, I'll let you know how the project goes and whatnot, and I'll post video pictures up on Google Plus of the progress as it commences. Really, I've already got a few up with this one. So I hope you all enjoyed, and I'll see you all again soon, guys. Take it easy. Cheers.